Many electricians utilize the National Electrical Code, or NEC, on disk, either as a standalone product or as part of a broader subscription service. This digital format provides several advantages over traditional printed codebooks. Firstly, the searchability of the NEC on disk is a significant benefit. Instead of manually flipping through pages, users can quickly search for specific terms or phrases. This feature greatly reduces the time required to locate relevant information within the code. Secondly, the hyperlinking within the NEC on disk enhances usability. Users can easily navigate from one section of the code to related sections with a simple click. This interlinking is particularly helpful for understanding the relationships between different code requirements and ensuring comprehensive compliance. Thirdly, regular updates ensure that users always have access to the latest version of the NEC. This is crucial for electricians working in jurisdictions that have adopted the most recent edition of the code, as it helps them stay current with the latest regulations and best practices. Fourthly, portability is a key advantage. The NEC on disk can be easily stored and accessed on laptops or tablets, enabling electricians to carry the entire code with them to job sites or meetings. This eliminates the need to transport heavy printed volumes and provides convenient access to code information wherever it is needed. Beyond these core advantages, the NEC on disk also facilitates the creation of custom reports and presentations. This feature can be valuable for electricians who need to communicate code requirements to clients, colleagues, or inspectors. The ability to easily extract and present relevant code information can improve clarity and understanding, leading to better compliance and safer electrical installations. To determine whether the NEC on disk is a worthwhile investment, consider individual needs and usage patterns. For electricians who frequently consult the NEC, the digital format can offer significant time savings and improved efficiency. The enhanced searchability, hyperlinking, and portability features can streamline the code lookup process and facilitate better understanding of complex requirements. However, for those who only occasionally need to access the NEC, the printed codebook may suffice. The decision ultimately depends on the frequency of use, the importance of staying up to date, and the value placed on the convenience and advanced features offered by the digital format. The NEC is a comprehensive set of standards designed to ensure the safe installation of electrical wiring and equipment. Its purpose is to protect people and property from hazards arising from the use of electricity. The NEC is updated every 3 years to reflect advancements in technology, new understandings of electrical safety, and evolving best practices. Staying current with the latest edition of the NEC is essential for all electricians and electrical contractors. The code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It provides detailed requirements for materials, devices, and systems used in electrical installations. Compliance with the NEC is often mandated by local, state, and federal regulations. Electrical inspections are typically conducted to verify that installations meet the code requirements. Failure to comply with the NEC can result in fines, project delays, and, most importantly, increased risk of electrical hazards. The NEC is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. Understanding the structure of the code is crucial for effectively locating and applying the relevant requirements. The index and table of contents can be valuable tools for navigating the code. In addition to the core requirements, the NEC also includes informative annexes that provide supplementary information and guidance. These annexes are not enforceable as code requirements but can be helpful for understanding the intent and application of the code. Electricians should be familiar with the specific requirements that apply to their work. This includes understanding the general rules applicable to all installations, as well as the specific rules that apply to particular types of equipment, occupancies, or wiring methods. Continuing education and training are essential for staying up to date with the NEC and best practices in electrical safety. Changes to the code can have a significant impact on electrical installations, so it is important to understand the latest requirements and how they affect your work. Many organizations offer training courses and resources to help electricians stay current with the NEC. These resources can include online courses, workshops, seminars, and publications. In addition to formal training, it is also important to stay informed about changes to the code through industry publications, online forums, and discussions with other electricians. Sharing knowledge and experiences can help improve understanding and application of the NEC. The NEC is a complex and comprehensive document, but it is an essential resource for ensuring electrical safety. By understanding the code and staying up to date with the latest requirements, electricians can help protect people and property from electrical hazards. Some specific examples of NEC requirements include conductor sizing, overcurrent protection, grounding and bonding, and wiring methods. Conductor sizing is determined by the ampacity of the circuit, which is the maximum current that the conductor can carry safely. The NEC provides tables that specify the ampacity of different types of conductors based on their size, insulation, and installation conditions. Overcurrent protection is provided by circuit breakers or fuses, which are designed to interrupt the flow of current in the event of an overload or short circuit. The NEC specifies the maximum size of overcurrent protection devices based on the ampacity of the conductors they protect. Grounding and bonding are essential for preventing electrical shock and fire hazards. Grounding provides a low impedance path for fault current to return to the source, which helps to trip overcurrent protection devices. Bonding connects metal parts of the electrical system together to ensure that they are at the same potential, which reduces the risk of electrical shock. Wiring methods refer to the way in which conductors are installed and protected. The NEC specifies different wiring methods for different types of applications, such as conduit, cable, and open wiring. Each wiring method has specific requirements for installation, support, and protection. The NEC also addresses specific requirements for special occupancies, such as hazardous locations, healthcare facilities, and swimming pools. These occupancies have unique electrical safety considerations that require additional precautions. Hazardous locations are areas where flammable gases, vapors, or dust may be present. The NEC specifies special wiring methods and equipment for these locations to prevent explosions and fires. Healthcare facilities have critical electrical systems that must be reliable and safe. The NEC specifies requirements for emergency power systems, grounding, and isolation to protect patients and staff. Swimming pools and other water features pose a risk of electrical shock. The NEC specifies requirements for bonding, grounding, and ground fault circuit interrupters (GFCIs) to protect swimmers and bystanders. Understanding and applying the NEC is essential for ensuring electrical safety in all types of installations. By following the code requirements, electricians can help protect people and property from the hazards of electricity. To delve deeper into specific NEC requirements, consider these examples. NEC Section 210.12 addresses arc fault circuit interrupter, or SI protection. SIs are designed to detect and interrupt arc faults, which are a common cause of electrical fires. The NEC requires SI protection in many residential circuits, including the serving bedrooms, living rooms, and dining rooms. NEC Section 250.50 covers grounding electrode systems. A grounding electrode system provides a connection to earth, which helps to stabilize the electrical system and provide a path for fault current to return to the source. The NEC specifies different types of grounding electrodes, such as ground rods, metal water pipes, and concrete encased electrodes. NEC Section 300.4 addresses protection against physical damage. The NEC requires that conductors and equipment be protected from physical damage that could compromise their safety. This can be achieved through the use of conduit, raceway, or other protective measures. NEC Section 310.15 provides ampacity tables for conductors. These tables specify the maximum current that a conductor can carry safely based on its size, insulation, and installation conditions. It is important to use the correct ampacity table for the specific type of conductor and installation. NEC Section 408.36 covers overcurrent protection for panel boards. Panel boards are enclosures that contain overcurrent protection devices, such as circuit breakers or fuses. The NEC specifies the maximum number of overcurrent protection devices that can be installed in a panel board based on its size and rating. NEC Section 430.52 addresses motor circuit protection. Motors are a common type of electrical load, and they require special protection due to their inrush current and potential for overload. The NEC specifies the maximum size of overcurrent protection devices for motor circuits based on the motor's horsepower and full load current. NEC Section 517.13 covers grounding in healthcare facilities. Healthcare facilities have critical electrical systems that must be reliable and safe. The NEC specifies requirements for grounding and bonding to minimize the risk of electrical shock to patients and staff. NEC Section 547.5 addresses wiring methods in agricultural buildings. Agricultural buildings, such as barns and poultry houses, often have unique environmental conditions that can affect electrical safety. The NEC specifies special wiring methods for these buildings to protect against moisture, corrosion, and other hazards. NEC Section 680.26 covers bonding of metal parts in swimming pools. Swimming pools pose a risk of electrical shock, and bonding is essential for minimizing this risk. The NEC specifies requirements for bonding all metal parts of the pool structure, as well as any metal equipment within a certain distance of the pool. These are just a few examples of the many specific requirements contained in the NEC. By understanding these requirements and applying them correctly, electricians can help ensure the safe and reliable operation of electrical systems. Furthermore, consider the practical applications of the NEC in various scenarios. Firstly, in residential wiring, the NEC dictates the placement and type of outlets required in different rooms. For example, it mandates ground fault circuit interrupter, or GFCI, protection for outlets in bathrooms, kitchens, and outdoor areas to prevent electrical shock hazards. Secondly, in commercial buildings, the NEC sets standards for emergency lighting and power systems. These systems are crucial for ensuring the safety of occupants during power outages or other emergencies. The code specifies requirements for the installation, testing, and maintenance of these systems. Thirdly, in industrial settings, the NEC addresses the specific electrical needs of heavy machinery and equipment. It provides guidelines for motor circuit protection, grounding, and wiring methods to ensure the safe and reliable operation of industrial processes. Fourthly, in healthcare facilities, the NEC has stringent requirements for electrical systems to protect patients and staff. These requirements include redundant power systems, isolated power systems, and equipotential grounding to minimize the risk of electrical shock and interference with medical equipment. Fifthly, in renewable energy systems such as solar photovoltaic installations, the NEC provides guidance on the safe and effective integration of these systems into the electrical grid. It addresses issues such as overcurrent protection, grounding, and disconnecting means to ensure the safety of both the system and the grid. Sixthly, in hazardous locations, such as chemical plants or refineries, the NEC specifies the use of explosion-proof equipment and wiring methods to prevent ignition of flammable gases or vapors. These requirements are critical for minimizing the risk of fire and explosion in these environments. Seventhly, in data centers, the NEC addresses the unique electrical needs of these facilities, which require highly reliable power systems to support critical computing infrastructure. It provides guidance on power distribution, grounding, and cooling systems to ensure the continuous operation of data centers. Eighthly, in telecommunications facilities, the NEC specifies requirements for grounding and bonding to protect sensitive electronic equipment from voltage surges and other electrical disturbances. These requirements are essential for maintaining the reliability of telecommunications networks. Ninthly, in transportation systems such as airports and railways, the NEC addresses the specific electrical needs of these facilities, including lighting, signaling, and communication systems. It provides guidance on the safe and reliable operation of these systems to ensure the safety of passengers and personnel. Tenthly, In marine environments, the NEC has specific requirements for electrical systems on boats and ships to protect against corrosion, moisture, and other hazards. These requirements are critical for ensuring the safety of electrical systems in marine applications. By considering these practical applications, it becomes clear that the NEC plays a vital role in ensuring electrical safety across a wide range of industries and environments. Its comprehensive requirements and continuous updates help to minimize the risk of electrical hazards and protect people and property. The National Electrical Code is more than just a set of rules. It is a living document that evolves to address the ever-changing landscape of electrical technology and safety practices.